Okay, welcome back everybody to Trigonometric Ratios. So we're going to be starting some topics of related to trigonometry. If you look at the word trigonometry, it can be broken down into two parts. Trig means triangle, so trigonometry. Metric means measurement, so trigonometry or trigonometric means triangle measurement. So we're going to be looking at how to measure triangles with this topic. And so today we're looking at the ratios, the three main trig ratios. So we'll start with those definitions and then work a whole bunch of examples after that. So let's look at the drawing I have here. You got a drawing of a triangle ABC. And trig ratios are talking about the ratio of two sides of a triangle, the ratio of two sides of a triangle. And the first one we're going to look at is the sine. So if you look at the triangle ABC, notice the vertices are using capital letters, and the sides directly across from those angles then are using the small letters. So small b is across from angle B, so small a, so side A is across from angle A, and side C with a small c is across from angle C. So that's a convention we're going to use. So when we talk about the sine of angle A, S-I-N, that's pronounced sine, by definition is the opposite leg of the right triangle over the hypotenuse. And by the way, these trig ratios are all for right triangles. So if you're standing right here on angle A, you've got the hypotenuse C, and then the opposite leg is A. The opposite leg is the one across from the angle you're talking about. And the adjacent leg is next to the angle you're talking about. So that's why we're talking about opposite and adjacent today. So the sine of angle A is defined to be the opposite leg divided by the hypotenuse. So in this triangle, that's small a over small c. Opposite leg divided by hypotenuse. That's the sine of angle A. And we're going to do some calculations with that here quickly. The cosine of angle A then is defined to be the adjacent leg divided by the hypotenuse. So if you're right here on angle A, the adjacent leg is B, and the hypotenuse is C. So B divided by C is the cosine of this angle. The tangent, which is the other of the major trig ratios that we're going to look at, is defined to be the opposite leg divided by the adjacent leg. So if you're standing here on angle A, the opposite leg is small a, and the adjacent leg is small b. So a over b is the tangent of that angle A. So you got a lot of stuff to remember there, but here's one way to remember it all. Just by these three fake words here, SOHCAHTOA. SOHCAHTOA. So the letters stand for something. The sine is the opposite leg over the hypotenuse. The cosine of an angle is the adjacent leg over the hypotenuse, and the tangent of an angle is the opposite leg divided by the adjacent leg. So if you can remember that, these problems will not be a problem for you. Okay, let's start out with this problem. We got triangle RST, and it has three sides, 5, 12, and 13. We recognize those as Pythagorean triples. And we're trying to find the sine of angle R. So the definition of sine, remember, was opposite leg over hypotenuse. So we're going to set up a fraction. The opposite leg from angle R is 12. So if you're up here, let me point, if you're up here at angle R, the opposite leg is 12 over the hypotenuse, so 12 over 13. 12 over 13. And we can get a decimal for that also by dividing by 12 by 13. So 12 divided by 13 is, I'm just going to round this off to 4 decimal places, 0.9231. So 0.9231. That's what you're going to get. When you use, if you knew that angle, you could just plug that angle in your calculator and get that. But we're going to get that from a fraction. Okay, cosine of an angle R. So again, you're standing up here on angle R, and you want the cosine of that angle. So it's going to be the adjacent leg, 5, divided by the hypotenuse, 13. So that fraction is 5 divided by 13 for the cosine of angle R. And again, we can get a decimal for that by just dividing 5 by 13. So 5 divided by 13 is going to give you 0.3846. So 0.3846. So you're going to see sines, cosines, and tangents given as fractions and as decimals. The tangent of angle S, if you go back to the definition of tangent, if you're standing right here this time on angle S, it's the opposite leg, which is 5 divided by the adjacent leg, which is 12, so 5 over 12. So the tangent of angle S is, as a fraction, 5 over 12. And then again, if we want a decimal for that, we can just go ahead and divide 5 by 12. So 5 divided by 12 is 0.4167, rounded off. Okay, so there's your first examples of using the trig ratios in a triangle. We're going to have more coming up, but that'll get you started on that. Okay, let me draw some new triangles here. So there's your old friend, the 30, 60, 90 triangle there. And we're asked to find the sine of 60. So we can do that actually two ways here, because remember, we can use the definition of sine, and we can also just put the angle this time, since we know the angle, into a calculator. And we're actually going to do both and see if they agree. So if you're right here standing on the 60-degree angle, remember sine of that angle is opposite over hypotenuse. So that's square root of 3 over 2. Opposite leg over hypotenuse, if you're at angle, the 60-degree angle is square root of 3 over 2. So you can leave it like that. Now you can also divide the square root of 3 by 2. So if I do 3 divided by square root of 3, I should say, square root of 3, just doing this on my calculator, divided by 2, that decimal is going to give you 0.8660. 0.8660. If I divide those two numbers into fraction. But if I just put 60 degrees in my calculator directly and hit sine of 60, should be no surprise that you're going to get this exact same decimal. So if you know the angle and the directions ask you to find the sine and they don't care about fraction or decimal, you can just use your calculator. But if the problem requires you to use a definition and give a fraction answer, you're going to have to know that definition of a sine. Okay, let's do another one like that. Let's take our other good friend, the 45, 45, 90 triangle. You see that there. We're supposed to find the cosine of 45 degrees. You can use either angle really there, because both of those acute angles are 45. So let's just say I use this lower one, this 45 degrees. So I got to remember the cosine of 45 degrees is adjacent leg over hypotenuse. Adjacent leg over hypotenuse. So that'd be the 1 over the square root of 2. Okay, so 1 over the square root of 2. And then I'm going to want to rationalize that denominator by multiplying by radical 2 over radical 2. So that would end up being the square root of 2 over 2. That's multiplying top and bottom by square root of 2. So if I just do that on my calculator, square root of 2 divided by 2, it's going to give you 0.7071. But now I'm just going to, since I know the angle, I'm going to put that 45 degrees in my calculator, 45, and then hit cosine. And again, no surprise, you're going to get 0.7071 exactly. Okay, so we got that cosine by using a ratio of sides of the triangle and by using a calculator. It gives you the same, it should be the same number. Okay, let's do another one of those with tangent, and then we're going to switch it up a little bit. Tangent 30 degrees. So you are standing this time right on this 30-degree angle. The tangent says we want the opposite leg divided by the adjacent leg. The opposite leg is 1. That's across from the angle. The adjacent leg is root 3. And so using the definition of tangent, we're going to say that's opposite leg divided by adjacent leg, 1 divided by square root of 3. Again, that fraction is not rationalized, so we're going to rationalize the denominator by multiplying by radical 3 over radical 3. So that'll give you radical 3 over 3. Multiplying top and bottom by square root of 3. Okay, so if I actually divide square root of 3 by 3, square root of 3 divided by 3, I get 0.5773. 0.5773. And again, if I just go directly to the calculator and hit tangent 30, so I'll put tangent 30, and you got to know how your calculator works. Again, it's 0.5773. It's just like the square root thing. So sometimes on some calculators, you're going to put the 30 in, then hit the tangent button. Some calculators, you're going to hit the tangent button, then put the 30 degrees in. You're going to get the same answer. Just know how your calculator works. And make sure it's in degree mode instead of radian mode. Okay, we got 3 more examples, which we're going to find this time the side of an angle, or side of a triangle. So we're actually going to put this stuff to use here. So if you look at this triangle, I got triangle ABC, and they're giving you angle A is 41 degrees. They're giving you side BC is 6.1. They want to find side AB. I'm going to call that small c, going by our new convention here. And so if I want to, I got to pick, am I going to use sine, cosine, or tangent? Well, remember, you only know this angle right here, 41 degrees. So you know the opposite leg, and you want the adjacent leg. So that's the O and the A. That's TOA. That's tangent. Tangent's opposite leg divided by adjacent leg. So you can set up an equation using tangent by writing tangent 41 degrees equals 6.1 over small c. Okay, now we just have to solve that for small c using our algebra skills, and that'll give us that side of a triangle. So I'm going to multiply both sides by c here, so that'll be c times the tangent 41 degrees equals 6.1. Just multiplied both sides there by c, and then divide. So you got c equals 6.1 divided by tan 41 degrees. Okay, now let's do that in the calculator. So again, you got to have some calculator skills here to do this correctly. If you get these keystrokes in the wrong order, you're not going to get the right answer. So I'm going to take 6.1 divided by, now you got to figure out how to do tangent 41 on your calculator. So divided by tangent 41 equals, I'm just going to give the final answer here. So I get 7.017. So that is this missing side of the triangle right there. Okay, so we actually used our trigonometry to solve for one side of a triangle. Did not use Pythagorean theorem like we used to do. Okay, let's do a couple more of those. Get the practice. So here we have a new triangle, triangle MNP. And again, we're given one angle, N is 20 degrees, and the hypotenuse here is 8.7. They want side MP. So we're going to call that small n here, across from angle N. Okay, so now again, here's how you need to think about this. You're right here at angle N, and you are looking for the opposite leg, and you know the hypotenuse. Well, that's the O and the H. That's the sine. Again, if you are right here, you know this 20-degree angle. You're looking for the opposite leg. You know the hypotenuse. That calls for the sine, and so you're going to use that to set up your equation. So the sine of 20 degrees. So the sine of 20 degrees is equal to the opposite leg, which is N, divided by the hypotenuse, which is 8.7. So in this equation, we're just going to multiply both sides by 8.7. So that's going to give you N equals 8.7 times sine of 20 degrees. Go ahead and put that all in your calculator all at one time. Just know how to use your calculator. You should not have to write down any numbers or use the memory or anything. Just what you see is what you get there. So 8.7 times sine of 20. I'm going to get 2.976 for this. 2.976. And that should be correct. Now, do make sure that it makes sense. It can't be longer than the hypotenuse, right? The hypotenuse is the longest side, so at least it checks from that standpoint. I forgot my units here, right? That should be centimeters. I think on that previous problem, let me go back. I think I needed inches on that. I got to be perfect here. Inches. Okay, we got one more. So we're trying to find side YZ here in triangle XYZ. YZ is across from angle X, so we're going to call that small x. And again, you're standing up here on that angle Z, and you're looking for the hypotenuse. You know the adjacent leg this time. So that calls for you to use cosine. Adjacent leg over hypotenuse. So we're going to say cosine of 38 degrees equals adjacent leg 12.6 divided by hypotenuse x. Adjacent leg over hypotenuse is the cosine. Let's multiply both sides by x there, so you have x cosine 38 degrees equals 12.6. Divide both sides by cosine 38 degrees, so x equals 12.6 divided by cosine 38 degrees. And then pull out the calculator and make sure you know how to use it again. So this time we have 12.6 divided by cosine 38. So this missing side x is 15 point, well, let's just call it 16. Close enough. It's 15.9896. So we'll call it 16. And do we have the units on that? Centimeters. So 16 centimeters. Okay. To recap what we're doing, there's really not a whole lot new. You do have to keep track of SOHCAHTOA, and I'm going to write that down one more time here so that you guys can see that. So SOHCAHTOA, this is what you need to take away from this lesson. SOHCAHTOA. First, you have to know how to spell that, right? Otherwise, it won't be helpful to you. You need to know that trig ratios are ratios of sides of a right triangle. We're using right triangles, and there are three of them. And the first one is a sine, which is the opposite leg over the hypotenuse. So you see the letters there. The cosine is the adjacent leg over the hypotenuse in a division problem. And the tangent is the opposite leg divided by the adjacent leg. So if you can keep all that straight, you're going to do pretty well in this assignment. Okay, well, there you go. Let's get some practice, and good luck.